Okay, so in this section we're gonna have a look at trigonometric functions and continuing our journey to define different types of functions. We've already talked about polynomial functions, we talked about power functions and rational functions, and the time has come for us to talk about trigonometric functions. And the most popular trigonometric functions are the functions the sine of x, the cosine of x, and tan of x. We also have cotan of x, but it's not as popular as these three. What makes these functions so useful is that they are repeating functions. If we were to graph the function the sine of x, it would look something like this, where this is the x-axis and this here is the y-axis. We see the function the sine of x becomes equal to 0 in x equals to 0, and it again equals to 0 at another point x, and so on so forth. After a period equal to 2 pi, the function the sine of x repeats itself. We say that the function the sine of x is repeating and it has a period of 2 pi. So the sine of x plus 2 pi equals to the sine of x. What this basically means is that there's no point in knowing all of the different angles that we can input into the sine of x, because knowing a couple of angles like the angles between 0 and 90 degrees will enable us to figure out what the sine of x will equal to for all different angles. A couple of different important angles that we should memorize is the sine of 0, which is equal to 0, the sine of 30 degrees, it's equal to 1 over 2, the sine of 45 degrees, it's equal to the square root of 2 over 2, the sine of 60 degrees is equal to the square root of 3 over 2, the sine of 90 degrees, it is equal to 1. Memorizing what the sine of x equals to for these different angles, that coupled with this identity, the identity that says the sine of alpha plus beta equals to the sine of alpha multiplied by the cosine of beta plus cosine of alpha multiplied by the sine of beta, and this plus sign should be a negative sign. Using this identity we can find the sine of different angles. Like for example, I want to find the sine of the angle 15 degrees. We know that this equals to the sine of 45 minus 30 degrees, because 45 minus 30 degrees is equal to 15 degrees. Let's expand. We'll have the sine of 45 degrees multiplied by the cosine of 30 degrees minus the cosine of 45 degrees multiplied by the sine of 30 degrees. And this equals to the sine of 45 degrees is equal to the square root of 2 over 2. And the cosine of 30 degrees, we haven't talked about cosine yet, but it's basically the reverse of sine. The cosine of 30 degrees is equal to the square root of 3 over 2 minus the cosine of 45 degrees is the square root of 2 over 2, and the sine of 30 degrees is 1 over 2, and this equals to the square root of 6 over 4 minus the square root of 2 over 4. And we can simplify this expression to be equal to the square root of 6 minus the square root of 2 over 4. So knowing the value of the function sine for these different angles will enable us that, coupled with this identity here, the sine of alpha plus beta equals to the sine of alpha multiplied by the cosine of beta plus cosine of alpha multiplied by the sine of beta, that coupled with knowing the value of sine at the different angles of 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees will enable us to find the value of sine for different types of angles that we haven't encountered yet, like the value of sine, the sine of 15 degrees or the sine of 75 degrees, and so on, so forth. And now we'll take a look at cosine. For cosine, the graph of the function something like this. It's a repeating function like the function the sine of x, and its period for repeating is also equal to 2 pi. So after 2 pi we get the same function cosine of x. The value of cosine when the input is equal to 0 degrees is equal to 1. The cosine of 30 degrees is equal to the square root of 3 over 2. The cosine of 45 degrees is equal to the sine of 45 degrees, which is equal to the square root of 2 over 2. And the cosine of 60 degrees is equal to a half. And the cosine of 90 degrees is equal to 0. And this here is the x-axis and this one is the y-axis. The most famous relationship that holds sine and cosine together is the relationship that states the sine squared of x plus cosine of x squared equals to 1. What this basically enables us to do is, if we had the value of sine at a particular degree, we can find the value of cosine at that degree, because cosine squared of x is equal to 1 minus the sine squared of x. If I had this thing, the sine of x, then I would square it. I'll take 1 from it, and that will equal to cosine squared of x. If I were to take the square root of both sides, I will get the cosine of x, which is equal to the square root of 1 minus the sine of x squared. And this here is the most important relationship in all of trigonometry. We also have an identity similar to this identity for sine, but this time for cosine we have the cosine of alpha plus beta equals to the cosine of alpha multiplied by the cosine of beta minus the sine of alpha multiplied by the sine of beta. This will also enable us to find the value of cosine at different angles that we haven't memorized, using the angles that we have memorized, like the angles 0 degrees, 30 degrees, 45, 60, and 90 degrees. And tangent is basically sine, the sine of x, divided by the cosine of x. The tangent function will have a domain of R, so the set of all real numbers, except for where cosine equals to 0. Because where cosine equals 0, the value of tangent will be undefined, because tangent at the end of the day is just a fraction. It's a sine in the numerator and cosine in the denominator, and the denominator should not be equal to 0. And so if it were to be equal to 0, then the tangent of x for those x's that make the denominator equal to 0 will be undefined. And while we're talking about the domain for the function tan, let's talk about the domain for the function sine. It's R, the set of all real numbers. There isn't any constraints when it comes to the input to the sine function. Similarly, the cosine function has a domain of R. But for the sine function and the cosine function, the range, the domain for the sine function is equal to R, and the domain for the cosine function is equal to R. But the range for the sine function is equal to -1 up to 1. And we see that evidently from the graph that we have graphed here. Similarly, the range for the cosine function is -1 up to 1.